Hi, good afternoon. This is Belinda Brown with Lake Nona Social. Today I have the pleasure to interview Siobhan Malany, and she wanted to talk about the last award that she was granted recently, and tell us about the research that he has been doing here for the Sanford-Burnham Institute, and tell us a little bit more about what is happening here in Lake Nona. So, Siobhan, would you mind telling us about yourself and what brought you here today?
Yeah, sure. So my background's really chemistry pharmacology, and prior to coming to Sanford-Burnham Prebys, I was in San Diego in the biotechnology industry in drug discovery, early stage drug discovery, and I wanted to bring the business of drug discovery into the academic setting here and the research setting, combine both the research and drug discovery here in the Chemical Genomics Center. And so that's really my background, and we've been focused on building disease models in cells, in human cells specifically, and then looking for therapeutics for specific diseases, whether they're diabetes, liver diseases, cancer, and all that, and actually building really relevant models that we can use for finding therapeutics to combat some of these diseases.
That's really, really cool. I didn't even know about all of this, before meeting you a few months ago, and I'm really excited to be able to share also some of your successes here at the Institute, but also with your own company that you have created recently. So we were, aware that you received an award, and it's in funds that you will receive, about $200,000 from Space Florida, that will help you to develop the next generation of lab on a chip. And I would love to learn a little bit more about this, because I made some research when I read the press release, and I think that our people and people living here would be really happy to know a little bit more about that as well.
Right, so the Space Florida actually provided some seed funding, and with that seed funding we created the first spinoff from Sanford-Burnham Prebys, which is called MicroGRX. And so that was established as an S corporation last year. And so with the Space Florida funds, this was to develop a partnership with a group in Israel to develop this lab on a chip. And so this is for microgravity type of research. And so we've been building this, and what we're interested in studying is muscle degeneration. So this weakness in muscle, and building a model. So, and microgravity really offers this very unique platform to study this changes in cells and how they grow and how they respond. So we know in astronauts that, particularly Scott Kelly, who's in a year in space, that there's this accelerated effect on muscle, that the muscle weakens quite quickly. And so we want to study this in cells, and there's an indication that these cells grow differently and respond differently. So, and of course we can't just throw cells up there, we need to be in this contained system. So we're developing this miniaturized, really lab on a chip that'll be quite small, something like this, where the cells can be inside these chambers, and this is really very beginning stage prototype, and where the cells are kept alive with the nutrients, and we can deliver the nutrients. We can look at how they grow and visualize them with optics, and we can download this data. It's all remote controlled. It will have a whole system of valves and pumps and be automated process and remote controlled, so that we can monitor these changes on the ISS, the International Space Station, as well as then bring the cells back and look at gene changes and expression changes. So all of this will hopefully then give us some more answers to develop some therapeutics for this muscle wasting or degeneration that occurs in the aging process, as well as in cancer. And so that is really the idea of using microgravity to have this platform where you have an accelerated time frame for which this occurs, and is indicative of the aging process. So in effect, Scott Kelly, when he was there for a year, he actually aged faster. And so can we recapitulate this in the cell environment for disease modeling? And that's really the take-home message. And also the other part of that is that when we study cells on the ground, we put them in plates, and they're two-dimension, which is not really typical of a tissue. So, but when they're in microgravity, you don't have the pull of gravity that actually grow a little bit more natural as a three-dimension tissue-like environment. And so we're going to take this, this really creates that better environment for a tissue. And then in the chip, you have the whole micro-physical environment to create more of this tissue-like disease model. So we're taking advantage of both of those aspects in terms of growth and in terms of the response and activity of these cells that will be a response that occurs faster than on Earth. And so this is really, we learn a lot when we go to space.
Yes.
And what we do, we learn a lot about what happens on the ground. And so we can start to really adapt this to finding new medicines and for degeneration in muscle and bone and changes in immune cells. All of these are really relevant to study, I think, in microgravity.
Yeah, that's fantastic to be able to use actually those space travel and journeys to be able to use and to see how the aging process and everything that is impacting us as human beings and people living in this community in Lake Nona. We are really actually interested in seeing how in the future it will impact health, medicine, and all of this. So do you have any other ideas about how this will impact medicine, but medication and everything in the future, and how it will also impact our industry here in Lake Nona, but also maybe nationally and globally, with the first findings and the first steps that you are taking today.
Right. Yeah. So the cells we're actually using are cells that are isolated from human muscle biopsies, and this is a collaboration with Florida Hospital. So we're using very relevant human and patient cells, and so these cells are actually are involved in this regenerative process. They create new muscle fiber in response to disease and to in the aging process. So these are the ones that we want to study in microgravity, and so this is a collaboration with Florida Hospital, and then with that is also developing this lab on a chip, which is really quite a hot area actually in general, because it does create this environment for organ growth, and so this pushes the technology even more. So I think in terms of the medical side, we're being able to use these human cells and then to hopefully develop therapeutics that would counter this weakness in this disease process. And also push this technology, and with the company be able to license in actually other lab on a chip technology that will be able to answer more challenging questions, look at different tissues, not just muscle, and really kind of advance both sides in terms of the life science medical side as well as the technology involved.
Yeah, so you just open the door for more actually questions and more answers and solutions that we might have in the future to explore other types of disease, not only the one some of the tissue that you are examining now, but also other one in the future, and giving the opportunity to other maybe labs to collaboration with you and other partners to create the technology then to go on the market and maybe commercialize one day some of those things.
Right, and the licensing opens up some really opportunity for other funding streams and other, eventually, hopefully, angel investors. But we started with the Space Forward seed funding, which was $200,000, and that created the company. And then we've just recently now received the award from CASIS, who's the Center for Advancement of Science and Space. They're funded by NASA, and so that's given us another over $400,000 to take this prototype and the human cell types, and actually it also pays for the whole flight, which will be a SpaceX flight to the space station. It also pays for the flight back of the cells in the system, that we can do more analysis on ground. So we have, so now we have this seed funding and this matching funds that's non-state, and we've hired a PhD level scientist to work on this. And so this is, continue, now we have to continue to build the technology, have some licensing opportunities, and then move into more of the investment opportunities that are out here in Central Florida for new businesses and for licensing from universities and institutes. So
that's wonderful.
That's the hope.
Yeah, and you seem to be really excited about this project, and I know that it's a lot more work now as well. And you just mentioned that you wrote somebody so it's fantastic to be able to see exciting things that are happening here in Lake Nona, in our backyard, really close to where we live and when we interact right. And I think that what I would like to have a little bit, a sense of, it's now that you have, this, first step, what, will come next for you? Because it's certainly a lot of work, a lot of exposure, visibility from other, partners. So I'm pretty sure that you are pretty busy as well, looking at what are the other, steps and all the moving parts around this project.
Yeah, so the CASES funding gives us the opportunity to do this proof of concept.
Yes.
So we'll be able to use these human cells, we're able to visualize them, measure some responses, look at the changes in gene expression. So that's going to be our proof of concept. And then after that is really to build on this and make it more of a drug discovery technology where we can look at different molecules or compounds, maybe a higher throughput instead of, we'll probably send maybe 3 chips, and expand on that in terms of being able to maximize the number of samples, the number of tests that the compounds you're looking at. So I think those are the future, is to expand that throughput and to be able to answer more with each flight and do a little bit more on the drug discovery side. So this is going to be the research proof of concept, and then we'll expand that out. And that's where the licensing of new technology, I think, comes into play as that advances. But you got to keep it simple for each. You get this one shot on the rocket. You've got to make it simple, so a lot of things can go wrong. We want to get the right answers and then be able to build on that, and move more toward the therapeutic side. And how do can you build a model? Then how do you counter this with a therapeutic so that you can use this for treatment of cancer? Muscle wasting is huge in cancer, immune deficiency diseases, aging process. So there's a lot of opportunity in terms of finding therapeutics and new medicines.
Yeah, that's terrific, and it's really inspiring. If I had a daughter, I would definitely have her to work in this industry, because it seems to be a lot of fun working with different people from different countries. I know that you are partnering as well with Israel, and having those really fun and also rewarding experience, because you are basically starting to change our environment and what medicine will be in the future. So I had another question, because when we came today earlier, we saw the lab, so we know that you had fantastic lab downstairs, that it's amazing. Would this data from the chip go in this lab and be treated over there too?
Yeah, absolutely. I mean, this is the thing. It's not a separate, isolated experiment. It's what we're doing in general when we are building these cell-based systems. We just use much robots and high throughput and multi-well plates and things like that to study the same thing. Now we're just, but a lot of times we have to induce the cells to be disease-like.
Yes.
Whereas, but that's necessary in order to screen lots and lots of compounds and find new medicines. But so here it's just an added dimension to that in terms of sending the same type of cells to the International Space Station to answer additional questions, to have this more natural environment where you have changes where you're not having to add a compound to make them, age or atrophy. You're just naturally occurring. The growth is more 3-dimensional growth, so it's just an added platform to study, and so it goes with all the things we're continuing to do in the Genomics Center in terms of our high throughput screening and disease drug discovery.
Wonderful, wonderful. So when is the next flight?
Well, 18 months is our time frame, so it's fast. So about a year of research development, and probably about another 6 months of safety regulations and flight preparation and all of that, flight integration, ground tests.
Yes.
So I'm hoping 2018, beginning of 2018, we'll be on a flight.
Okay, so yeah, keep us posted, because I'm pretty sure that people will want to know more, and it will certainly happen in our backyard. I'm pretty sure from Cap Canaveral, or if not, maybe not, but hopefully it will be from here, and it will be
that's the great thing. I got involved with this more or less because of the proximity to Kennedy Space Center, and just started going to workshops, and everything was changing from 2011, the end of the shuttle period, to the rockets and the creation of CASES, really, and Space Florida was coming together, and they're looking for experiments and things to do that make sense. And so it was just timing and proximity, and otherwise, this I didn't come to Sanford-Burnham to do space-related research. This is just this just happened. It was an incredible opportunity, and one I think that's going to open up a lot of doors in terms of both the research and both the small business entrepreneurial side as well.
Perfect. Do you have anything else that you would like to share with us? Because I think that we have covered a lot already, and you have shared a lot of your wisdom and information about what you have been trying to accomplish here and moving forward one step at a time. I had really the pleasure to meet you a few months ago, and I'm really excited for what you have been able to accomplish. So congratulations, and let us know if you have anything that you want to share today.
Yeah, I think the whole why do things in space is
Yes.
becoming much more relevant, and there's a whole other side as well. This is disease modeling, but then the other area that's really getting exciting is this whole organ transplant area, because there's this idea that cells in this precursor or stem state that we call that's before they become tissues, that this regeneration process is slow, that they stay in the stem state, and so I think some of the benefits we've accomplished from crystallography studies and building crystals can be applied to cells. So if you can actually almost bank stem cells and generate organs, there's this excitement that you could potentially sort of build organs in space for transplant, and that's also a huge area that I think is going to really explode.
This is amazing. Yeah, this is exciting. So, learning a lot more about your industry and what you have been able to accomplish, and how it will actually impact my life in the future and the life of my children as well. So it's amazing.
So that could be a real big avenue,
yes.
I think, in terms of opportunity and research.
Good.
But step by step, we're going to go for our first flight.
Yes.
We're going to keep the cells alive, get some good data, bring them back.
Yes.
That's the objective.
Perfect. But please, keep us, posted. I think that, Omar, myself, and the entire Lake Nona community would love to learn more and to continue to learn about the research, but also the application and the technology that will be developed, and also opportunity for businesses in the area and hopefully in the world. So thank you so much for your time.
Thanks.
Siobhan.
Thank you.
Thank you. Thank you.